Hey folks, Professor Gray here, ready to do some Chapter 7 extra practice, confidence intervals and the like. So let's start with number 1. Find z sub alpha over 2 for a 97.5 confidence interval. Use appropriate notation around 2 places. Alright, first I'm going to start with a sketch. That always helps me. Now in confidence intervals, your confidence level is always in the middle of the distribution. So I have 2 tails, and in the middle I have 0.975. Z sub alpha over 2 is the right-hand z-score, this one, because alpha over 2 is going to be left in the tail. All right, well, let's find alpha and then alpha over 2, and we'll go from there. First, I take 1 and subtract the area in the middle. That's the area in both tails combined. So divide it in 2 since they share it. And 0.0125 is in each tail. If you add up all 3 of those numbers, you'll get 1, or 100%. Now I just need the z-score on the right-hand side. So I'm going to use the command inverse norm. The total area on the left is going to be 1 minus 0.0125. 0 and 1 are the mean and standard deviation. Let's scoot that over so you can see the command. Let's type that in. Second vars, number 3. I can type in 1 minus 0.0125. Just like that. It's a z-score, so it's standard normal. And there's my answer. To 2 places, I get 2.24. Excuse me. Now for number 2. 2 says find t sub alpha over 2. Notice there's a t. For a 98% confidence interval if the sample size is 15. Alright, so this is similar in the sketch. Oh, pardon the sketch, it doesn't look very good. 0.98 is going to be in the middle. So we know there's going to be 1% in each tail. You can use the calculator for that if you need to. T sub alpha over 2 is on the right-hand side. Now, since this is a t distribution, we need to find the degrees of freedom. The sample size is 15, so the degrees of freedom, that would be n minus 1, which is 15 minus 1, which is 14. And now we can use one of the tables. All right, here's the t distribution critical t values table. You can do either the area in one tail or 2. I'm going to use one tail. So area in one tail will give me this column. And 14 degrees of freedom gives me this answer, 2.624. That is the answer. I don't have enough room to really write that beside the label, so I'll write on the left-hand side, 2.624. There we go. That's the answer. Straight from the table. T stands for table. All right, number 3. Number 3 says, which of the following is the best definition of a confidence interval? 2 values that the population mean could be with a certain level of confidence, a range of confidences for the mean of the sample, an exact value for the population parameter with a certain level of confidence, or D, a range of values used to estimate the true value of a population parameter, confidence levels, the probability the interval actually contains the population parameter. D is the definition of a confidence interval. You're finding a range of values to estimate whatever that true unknown value is. All right, number 4. Number 4 says, what's the effect on the width of a confidence interval if you increase the confidence level while all the other variables stay the same? Okay, if you increase your confidence level, let's say you start at 90% and then you go up to 99%, the width of it will increase. So, the confidence interval will become wider. So if your confidence level goes up, the width of the interval will go up. I'm 100% confident that all humans are between 1 inch and 1,000,000 inches tall. Yeah, I'm so confident because my interval is so wide. And vice versa. Number 5 says, what's the effect on the width of a confidence interval if you increase the sample size while everything else stays the same? Well, if you increase the sample size, you're going to get more accurate results. You're going to get more precise results. Your precision will go up, and that will make the confidence interval more narrow. You have more of a sample to look at, you're going to learn more and get more useful results. Yeah, become more narrow. So if you increase the confidence level in number 4, you'll get a wider interval. If you increase the sample size, then it will get more narrow and squeeze in. Number 6. Number 6 says, for this confidence interval that's given to you, what's the sample mean? That's another word for a point estimate. And the margin of error. Okay. The way we can do this is by a couple of quick formulas. The point estimate can be found by taking the upper number, I'm going to use U for upper, adding the lower number and dividing by 2. It's the number in the middle. The margin of error, that's E as notation, is found by taking the upper number and subtracting the lower number and then dividing that amount by 2. That's half the distance of the interval, or the distance between the middle and the ends. All right, well, let's do that. So first, the sample mean, that's the point estimate. So X bar will be 974.02 plus 778.04, all divided by 2. If you type that in the calculator, be sure to put parentheses around the top part, or do the top part and then divide the answer by 2 so that everything's in order. And there's my answer for the sample mean. X bar is going to be 876.03. All right, I'm going to circle that so I'll know where it's at later. Let's put a divider in there. All right, now for the margin of error. I'm going to have the same numbers, but this time I'm going to subtract them. Subtract first, divide by 2, and I get the margin of error, 97.99. And that's the answers. Here comes number 7. This time I'm given another confidence interval. This one is for proportion. That's why there's a lowercase p in it in the middle. What's the sample proportion? Again, that's the point estimate and the margin of error. Use notation. All right, so for the sample proportion, that's p hat. Again, I'm going to take the upper plus the lower and divide by 2. So if I do that, my upper number, 0.1203, plus the lower number, 0.0934, divide by 2. Let's see what we get. All right, the problem says to round to 4 places if necessary, so we will. You get a 0.1069. That's p hat. Now for the margin of error, similar deal, just going to subtract instead. .0934 like that, over 2. Move that over to where you can see it. Just a second on that. And you can see what's going on. Divided by 2 and round to 4 decimal places, I get about 0.0135, and that's it. So for number 7, there's my p hat and e. Number 8 says the prices in dollars for a particular camera are shown. Estimate the mean price for the camera with a 95% confidence level. If necessary, round to 2 decimal places. Okay, first thing I need to do, since I have a list of numbers, is put those numbers in my list in the calculator. Again, you can get to your list by going to Stat and pressing the Enter button. Clear off anything that's in your list if there's something already there. Alright, once I'm done putting things in my list, I go back to the main menu by pressing Second and Mode. Now I'm ready to find this confidence interval. Let's figure out what type of interval this is. I'm estimating the mean, so it's either going to be a t interval or a z interval. Do I have the population standard deviation? No, I don't. The standard deviation I use will have to come from these numbers, and these numbers are a sample. So I'm just going to jot down that this is a t interval, so I don't forget. Stat test t interval. And since I have my numbers in a list, I can go to Data, if it's not already highlighted, tell it it's list 1, frequencies 1, and 0.95 is my confidence level. When I hit Enter, it thinks for a moment, and it gives me the answer. It says if I need to round to 2 decimal places, it gives me the answer in 2 decimal places, so let's just leave it like it is. First number is 205.19. That's less than, now this is for a mean, so mu is the symbol, less than 230.21. That's the answer. You have to have both numbers. Don't forget your notation. It's a mean, so there's a mu in the middle. Number 9 says to interpret the interval that we just found. Okay, there's a useful template for this in the notes. We'll do this. We are, all right, your confidence level is 95, so 95% confident that the population, well, this is for a mean, so population mean price of the camera, this is me relating it back to the problem, is between the lower number, that's why we rounded to 2 places, it's in dollars and cents, and the upper number. $205.19 and $230.21. There's the interpretation. Number 10, a poll of 763 adults found that 43% said they would travel to outer space if they were given the chance. Estimate the true proportion of adults who would like to travel to outer space with a 95% confidence. Round to 4 places. All right, we're estimating a proportion, so this is going to be a 1 prop z interval. Make sure you go to interval, not test. That's for another time. Now, if you go to 1 prop z interval, there it is. You notice there's an x and an n. X is the number of times it happened in your sample, number of occurrences in your sample. N is the sample size, just like always. All right, so let's take a look at this problem. It says that out of 763 adults, so we know that N's got to be 763, 43% would travel to outer space. Oh, well, that's not a number. If I try to put in a 0.43 and a 763, I'll get an issue with the calculator. The calculator won't understand that. You have to put in the actual number of occurrences. You can't put in a proportion or anything like that. Okay, so we got to fix it. Here's what we do. We need 43% of 763. So 43.43 times 763. All right, 0.43, 763, and I get a number, but notice the number is not a whole number. When that happens, round that number just like you normally would to the nearest whole number. So this would be 328. So X is going to be equal to 328. Now let's go back and find the interval. X is 328. N is 763.95. Calculate. We'll round that to 4 decimal places, and that is our answer. All we have to do is write it out. 0.3948 is less than P, population proportion, which is less than 0.4650. There's a P in the notation because this is for a proportion. Let's do another one. Number 11. A sample of the reading scores of 35 fifth graders has a mean of 82. Standard deviation of the population is known to be 15. Find a 99% confidence interval for the mean reading scores of all 5th graders. Round to 1 decimal place. All right, this one's for a mean. So it's either a z or a t interval. The standard deviation is from the population, so it's a z interval. I'm going to jot that down. We don't have a list this time, so I'll go over to stats for the input, press enter. Sigma's standard deviation of the population. X bar is the mean of the sample. N is your sample size. And there's the answer. Rounding to 1 decimal place, I get 75.5. And the upper number is 88.5. There we are. Number 12. 12 says a sample of 15 race car drivers has a mean age of 33.6 years and a standard deviation of 7.7 years. Make a 90% confidence interval for the mean age of all race car drivers and round to 1 place. Again, this is for a mean, so it'll either be a z or a t interval. The standard deviation is 7.7, but is that for the population or a sample? Yeah, the way this reads, the sample has this standard deviation. So number 12 is going to be a t interval. Again, make sure stats is highlighted. Start filling in your information. All right, we're rounding to 1 decimal place for this one. So we get 30.1 is less than mu. Again, mu because it's a mean, which is less than 37.1. Number 13, a random sample of the number of farms in thousands in various states follows. Construct a confidence interval for the mean number of farms per state with a 90% confidence. Assume that sigma is 31. Round to 3 places if you have to. All right, it's for a mean, and they give you sigma, so this is going to be a z interval. Z is in zebra. You know, it's not really if you have standard deviation or not, it's where it's from. This one's from the population, so it's a z. If it's from a sample, it's a t. Have a list, so go to stat and enter. And get rid of your old list. Highlight L1, press clear and enter, and then type in the other ones, the new numbers. There we go. There's 10 of them, 10 numbers. We're set. I'll press stat, test, go over to z interval. I have a list, so select data, sigma 31. Everything else stays the same, but change the confidence level. And we get the answer. Let's round up to 3 decimal places. Well, it already came out in 3 places. Works for me. And there we go. For the rest of these problems, let's find a minimum sample size. Number 14 says, a pizza shop owner wishes to find the 95% confidence interval for the population mean cost of a large pepperoni pizza. How large should her sample be if she wishes to be accurate within 15 cents? Use notation. Previous studies showed that the standard deviation of the price is 26 cents. So this is a minimum sample size problem. I know that because of this wording. How large should her sample be? Let's try saying that 3 times fast. Well, it's either for a mean or a proportion. This one's for a mean. So let's go over to the formula sheet. Sample size determination for a mean. It's the very last one on that page. That's the formula we'll use for 14. Back to our problem. Now we just need to find all the parts that go into this formula, and the calculator will do the rest. First off, z sub alpha over 2 for a 95% confidence level. That's the critical value for that confidence level. If you've forgotten what it is, you can look on the positive z-score page down at the bottom right-hand side in the margin, and it's 1.96. How about sigma? Well, sigma is going to be the population standard deviation, 26 cents. And E, the margin of error, within 15 cents. Anytime you see the word within in these types of problems, that's probably going to be the margin of error. Now you can type that exactly as it's shown into your calculator all on one line. The calculator will have no problem with it. What you want to do is open with a parentheses first, and then type in the top, type in the divide, then be sure to close the parentheses and square everything. When you do, you get your answer. So according to this, n should be 11.54 approximately. But wait a minute, this is a sample size. You can't have 11.54 people or 11.54 I don't know, I guess this would be pizzas that you're sampling. You can't have 11.54 pizzas. You're not going to order that. You're not going to order 11.54. Okay, you need at least this many, so you have to round up. The answer is actually 12. She should get a hold of 12, easy for me to say, pizzas, and find out their cost. If she does more, great. She'll have more accurate results, but at least 12 to do what she's trying to do later on. Number 15. Says, how large a sample is necessary to estimate the true population proportion of unmarried Americans within 2.5 percentage points with 90% confidence? All right, how large a sample is necessary? So it's a minimum sample size. And it's asking about a proportion. So I'm going to use one of the minimum sample size proportion formulas. There they are. The next question is if I know p hat and q hat, or not so much. Do I have a sample proportion to go off of? And in this problem I do not. So I'll use the second formula. Let's find what we need to substitute in. It's a 90% confidence level, so z sub alpha over 2 would be the critical value for that 90%. Again, if I need to, I can go to the positive z-score page. There it is, 1.645. Now for the margin of error within 2.5 percentage points. Now anytime that it's worded that way, move the decimal and convert that number to a decimal number, not a percent, not a percent, but a proportion. So move it over, you get 0.025. And the calculator will do the rest. Again, you can type that all on one line. It won't hurt anything. 0.25 first. Don't forget the parentheses. Well, you can't sample 1,082.41 Americans, but you need at least this many, so round it up to 1,083. If that had been a whole number, I would have left it alone. If it's not a whole number, round it up. All right, number 16, last one. 16 says if a sample of 100 Americans has 23 that are not married, then how large a sample is necessary to estimate the true proportion of unmarried Americans within 2.5 percentage points with 90% confidence? So the same problem as before, but now we have a sample to go by. We'll use the other formula. Where p hat and q hat are known, because we can find those numbers. So what is p hat? I'm going to think over here to the side. Your sample proportion was 23 out of 100. Which is 0.23. Okay, well what's q hat? Q hat is 1 minus p hat. That's 1 minus 0.23, which is going to be 0.77. Now let's substitute in some. 0.23, 0.77. About z sub alpha over 2. Again, it's a 90% confidence level, so that didn't change. 1.645. Margin of error still within 2.5%, 0.025 as a decimal. So the only difference in 15 and 16 is I have somewhere to start. I have sample data, so I put that in, p hat and q hat. You can type this into the calculator as it's shown as well. Just be sure to use the parentheses. Don't forget to square at the end. And to get my answer, you can't survey 766.8 Americans, so round that up, you get 767 as your minimum sample size. Here's all of number 16 again.